An object moves horizontally and follows an equation for its location in meters as a function of time in seconds as x of t equals t squared plus 2 over 2t plus 1 for t between 0 and 4 inclusive. Determine the parts a through g. So our position function of time here is a quotient t squared plus 2 divided by 2t plus 1. For part A, we want to find the velocity as a function of time, and that is the derivative of the position function of time and is therefore a quotient rule. The derivative of the numerator, 2t, times the denominator left alone, 2t plus 1, minus the numerator left alone, t squared plus 2, times the derivative of the denominator, which is just a 2, all over the denominator squared. Now in the numerator, I'm going to distribute the 2t into here. That will give us 4t squared plus 2t. And I'm going to distribute the minus 2 into here. And that will give us a minus 2t squared minus 4. And then all of this will be divided by the 2t plus 1 squared. Combining like terms together in the numerator, a 4t squared minus a 2t squared is 2t squared. We also have the plus 2t and the minus 4, and then all of that divided by the 2t plus 1 quantity squared. So there's our velocity function of time. For part B, we want to find the time or times when the velocity is a 0. We have a quotient for the velocity function of time. To have the velocity be a 0, we need the numerator to be a 0 because 0 over any non-zero number equals 0. So only the numerator. 2t squared plus 2t minus 4, we want that to be a 0. That can factor. Let's start with a common factor of 2, leaving us with t squared plus t minus 2. That can trinomial factor. So we need two numbers that multiply to be a negative 2 and add to be a positive 1. It sounds like positive 2 and negative 1 will take care of that. And that means we end up with possible t values of negative 2 and 1. However, we do not keep negative times, only positive times, and so 1 second is the only time I'm going to keep here. That will be the time when the velocity is 0. It may also be a turnaround time. Now for part C and part D, we want to find the maximum horizontal location reached and the minimum horizontal location reached. Those are going to occur at either the initial time over here, that's the time of 0. Any times when the velocity is a 0, as they may be turnaround times, that would be here, the 1 second, or the final time back over here, that's at the 4 seconds. We want to find the position at each of those. So I'm going to calculate now the position at the initial time of 0, the position at the 0 velocity time of 1, which may be a turnaround time, and the position at the final time of 4. And these are determined by plugging these times into the position function. So x of 0 will be 0 squared plus 2 over 2 times 0 plus 1. 0 squared is 0 plus 2 over 2 times 0 is 0 plus 1. 0 plus 2 is 2. 0 plus 1 is 1. 2 over 1 is a 2. We're in units of meters. It will be located at 2 meters at a time of 0. Now at 1, we'll have 1 squared plus 2 over 2 times 1 plus 1. 1 squared is 1 plus 2. 2 times 1 is 2 plus 1. 1 plus 2 is 3. 2 plus 1 is 3, and 3 over 3 comes out to 1 meter. It's actually moved backwards. It started at 2 meters, it's now at 1 meter. And now, x at a time of 4, 4 squared plus 2 over 2 times 4 plus 1. 4 squared is 16 plus 2. 2 times 4 is 8 plus 1. 16 plus 2 is an 18, and 8 plus 1 is a 9, and 18 divided by 9 is 2 meters, and it's actually moved forward again. That means the 1 second was a turnaround time. It moved from 2 to 1, and then from 1 it turned around and went back towards the positive or more large numbers and went back to 2 meters. For part C, the maximum horizontal location reached, x max, is going to be found amongst the set. We want to find the largest values from here, and that turns out to be at 2 spots. The 2 meters and the 2 meters are the largest, and that occurred at a time of the initial and final times of 0 and 4, and was equal to 2 meters. The minimum horizontal location reached for part D will also be found amongst the set. That'll be the 1 meter. That's the lowest value up there, and that's occurring at the 1 second time. And there's our x-min location of 1 meter. What the object is doing here is it's starting at a time of 0 at a location of 2 meters. It's then moving backwards, and by the time of 1 second, it's at a location of 1 meter. It's then turning around and moving back, and by a time of 4, it's returned back to the 2 meters again. Now for part E, we want to determine the total displacement of the object. The total displacement is how far its final location is relative to its initial location. How far apart are they? And that's always found by the position at the final time minus the position at the initial time, x of 4 minus x of 0. Well, we found each of those, and they are both 2, so we will have 2 minus 2, or 0 meters. It displaced by 0 meters, and we can see that in the picture here because it did end up where it began. For part F, we want the total distance traveled. The total distance traveled is how far it traveled for the first piece, that's here, and how far it traveled for the second piece, that's here. We want those to be positive numbers and add them together. That will not be a 0 because it definitely traveled a distance during this motion. Because it turned around, we have to make sure that when it's moving backwards, that comes out to a positive number. And that was this first piece here. That was actually when it was moving backwards. But it's always done by taking the absolute value of the different sections. We have the final minus the turnaround time piece, and then we have the turnaround time minus the initial time piece. And we want to take the absolute value of each of those. Now this piece here, which is corresponding to this here, will be the negative number because that's when it's moving backwards, but the absolute value will make it positive. Now we have these numbers up above, so x of 4 is a 2, x of 1 is a 1, plus, and then x of 1 is a 1, and x of 0 is a 2. So we have the absolute value of a 1 plus the absolute value of a negative 1, and that absolute value will make that negative 1 become a positive 1, and that's how we can combine these together as positive numbers, and that gives us the total distance traveled. It actually traveled a total distance of 2 meters, but it displaced 0 meters because it ended up where it started. For part G, we want to find the acceleration as a function of time, and the acceleration as a function of time is the derivative of the velocity function of time. The velocity function of time is here. We're going to take the derivative of that. That's once again a quotient rule. Derivative of the numerator, 4t plus 2, times the denominator left alone, 2t plus 1 squared, minus the derivative of the denominator times the numerator left alone. So we'll leave the numerator left alone here, and then multiply it times the derivative of the denominator, which is bring down the 2, subtract 1 from the power, and multiply by the derivative of the inside. All of that will be over the denominator squared. Now in the numerator we have a common factor of 2t plus 1 in each of these terms. We can factor that out, If we factor that out, it'll take the one out here, and it'll take one of these here. And that will leave us with 2t plus 1 times, we will have a 4t plus 2 times a 2t plus 1 minus, and we've taken the 1 out here, we have the 2 and the 2, I'll put those in the front, 2 times 2 is a 4. So we'll have a 4 and then times the 2t squared plus 2t minus 4. And then all of that over, in the denominator, 2t plus 1 squared and then squared again. In that case, you multiply the exponents, and that'll be to the 4th power. However, in the numerator, we just factored a 2t plus 1 out, so we can cancel with one of them in the denominator, and that will give us a 2t plus 1 cubed. Now back in the numerator, we are going to want to FOIL this out, and that will give us, first, 8t squared, outside a positive 4t, inside a positive 4t, and last, a positive 2. And we're going to want to distribute this negative 4 into all of this. And that will give us a negative 8t squared, a negative 8t, and a positive 16. All of this over the denominator, which we'll just leave alone, so it's just 2t plus 1, and then cubed. So we can now combine like terms in the numerator. The 8t squared terms will fully cancel. The 4t, and the negative 8t will fully cancel. And we will have a 2 plus a 16, which is 18 over 2t plus 1 quantity cubed. That's as simple as we can make it. So there's our acceleration function of time, 18 over 2t plus 1 cubed.